All right, so we should all be on 17.4 on page 118. Today we are talking about exponents. So exponents is something you've hopefully done a little bit of in 5th grade, probably not a lot though. So in the video last night, we talked about perfect cubes, perfect squares, things like that. So this says, make sure to include correct units of measurement as part of your answer. Question 1. A square has a side length 10 centimeters. Use an exponent to express its area. All right, so if I have this square, its side length is 10 centimeters. It's a square, so all of its side lengths are 10 centimeters. So I'm doing length times width. The length is 10, and the width is 10. So what they're saying is rather than solve that, rather than do 10 times 10 is 100, they want you to write that with an exponent. So an exponent is just this little number up here. So if I look at the number 2, that's an exponent. So 10 times 10, I would write that as 10 to the second power. 10 raised to the second power. All right, any questions on that? All right, if I look at number 2, it says the area of a square is 7 to the second square inches. What is its side length? So in this case, 7 to the second power means 7 times 7. All right, so this right here is how they're finding. They're doing length times width. So they just did this backwards, basically. They're saying, well, this was 10 to the second, which is 10 times 10. So the length and the width were both 10. In this one, they're saying, well, the area is 7 to the second. What's the side length? So the 7 to the second is 7 times 7. That is the length, that is the width. So the side length for this square would be 7 inches. All right, if I have this square, it would be 7 inches on each side. Any questions on that? Any questions? All right, let's look at number 3. It says the area of a square is 81 meters squared. Use an exponent to express this area. So now they're saying when I did length times width, I got 81. So it's a square. So I know this side and this side have to be the same length. In order for it to be a square, the sides have to be the same length. So I'm trying to figure out what do I multiply together to get 81. So what two numbers can I multiply together to get 81? So I'm thinking, does 2 times 2 work? Does 3 times 3, 4 times 4, 5 times 5? That's what I'm kind of running through in my head right now. So I know 5 times 5 is 25. That's way too small. 7 times 7 is 49, that's way too small. 8 times 8 is 64, that's still too small. 9 times 9 gets me 81. So to get that 81, I'm doing 9 times 9. All right, so how do I express that with an exponent? 9 times 9 is 9 to the second power. All right, so this is how I would express that with an exponent. All right, any questions on that one? I see Michaela and Alex, thank you for throwing in that answer for me. I'll appreciate it. All right, so now we're going to do basically the same thing, but instead of talking about squares, we're talking about cubes. So now we're dealing with cubes. So just like a square has 2 equal sides, a cube is going to have all faces are equal, the length, the width, and the height are all equal. So the first one says a cube has an edge length 5 inches. Use an exponent to express its volume. So my cube has an edge length 5. That means all of the edge lengths are 5 inches. So to find the volume of a cube, I do length times width times height. So the length, the width, and the height, those are all 5. Length times width times height. So that's 5 times 5 times 5. So when I had 10 times 10, that was 10 to the second. 7 times 7 was 7 to the second. 9 times 9 was 9 to the second. Now I have 3 5s. I'm doing 5 times 5 times 5. So that's going to be 5 raised to the third power. All right. Number 5. Now they want to know. Oh, I'm sorry. Any questions on number 4? All right. Number 5. The volume of a cube is 6 to the third centimeters, cubic centimeters. What is its edge length? So now they're saying, well, if the volume is equal to 6 to the third, 6 to the third is 6 times 6 times 6. So to find the volume, I'm doing length times width times height. So the length is 6, the width is 6, the height is 6. So the edge length would have to be 6 centimeters. Any questions on that one? All right, let's look at number 6 now. So a cube has edge length S units. Use an exponent to write the expression for its volume. So this one gets a little weird because there are no numbers. So this isn't something we're probably super used to coming into 6th grade. But saying, well, what if the side length was S? Meaning I don't know the side length. It could be anything. I have no idea what it is. It could be anything. I still do volume equals length times width times height. Now the length is S, the width is S, and the height is also S. So just like here, 5 times 5 times 5 was 5 to the third. 6 times 6 times 6 was 6 to the third. S times S times S is going to be S to the third. All right. And if that one's a little confusing, don't worry too much about that. You're not going to really see what we call variables all that much. That's that letter S. S is considered a variable. All right. Any questions on that activity? All right, we're going to jump ahead to 18.2 now. 18.2. All right, so we're going to look at these two problems now. So they're both talking about cubes. So number 1 says, a cube has edge length 5 inches. Draw a net for this cube and label its sides with measurements. So I'm going to look at this cube. I'm going to draw this cube as a 3D shape first. All right, so it's 5 inches, so all of its sides are 5 inches. All of its edge lengths are 5 inches. All right, so it says draw a net for this cube and label its sides with measurements. So when I draw the net, I always start with the base or the bottom of my shape. So I'm going to start with the bottom, and that bottom is 5 by 5. What I do from here really doesn't matter, but I'm going to start, I like to go to the right side next. I'm going to fold down this side of my cube. It's also 5 by 5. I'm then going to take the top and flip that over with this. The top is also 5 by 5. I'm then going to take this left side that we can't really see. So over here would be a side I cannot see. And I'm going to flip that down. It is 5 by 5. I'm then going to flip the front down. The front is also 5 by 5. I'm going to flip the back down. The back is also 5 by 5. So because it's a cube, all of its sides are exactly the same. They're all 5 by 5. All right. So any questions on how I drew that net? Because that's going to be important. Can we draw a net? That's going to be a very important skill. All right. So what is the shape of each face? So the face is like the 2D side of the 3D figure. So the face in this case, they are all squares. What is the area of each face? So each face is a 5 by 5 square. So to find the area, I'm doing length times width, 5 times 5. So the area of each face is 25. All right. I could also have written this 5 times 5 is 5 squared. If I think back to my exponents, 5 times 5 is 5 squared. All right, D, what is the surface area of this cube? So if all the faces are exactly the same, they're all 25. They all have an area of 25. So this is 25, that's 25, that's 25, that's 25, that has an area of 25, and that has an area of 25. All 6 faces have an area of 25. So I could do 25 plus 25 plus 25 plus 25 plus 25 plus 25, but I think it's a lot easier to do 25 times 6. Gets me 150 square inches. All right, I could have also added those together, 25 plus 25 plus 25 plus 25 plus 25 plus 25. Would have gotten me 150 as well. All right, what is the volume of this cube? So to do volume is all for a rectangular prism. A cube is a rectangular prism. I do length times width times height. All the side lengths are the same. All the edges are the same. So the length is 5. The width is 5. The height is 5. So I could write this as 5 to the third if I think back to my exponents. The answer, we want to actually solve it out. 5 times 5 is 25. I have this other 5. 25 times 5 is 125 cubic inches. Any question on D, really A, D, or E? Those are the ones you're going to need to be able to do. You need to be able to draw a net, find surface area, find volume. Those are going to be the important ones for your test next week.
Mr. Hagedorn?
Yes, Alfonso.
Can you give me like 10 more minutes because I still need to finish my independent work.
No, the whole class can't wait 10 minutes for you to finish, man. Like, that's the end of class by then. The whole class can't wait. We're going to go. If you don't finish, that's okay. It's not a big deal if you haven't finished. All right, but we need to keep going. All right, number 2. A second cube has an edge length 17 units. All right, so I'm going to first draw the cube because I like to have the 3D figure to look at. All right, so the length is 17, the width is 17, the height is 17. Because it's a cube, all of those edge lengths are exactly the same. All right, so draw the net. Again, I always start with the base. I'm going to start with the bottom. It's 17 units by 17 units. I then fold down the right side. This side right here is 17 units by 17 units. I then like to flip the top over. That's 17 units by 17 units. So I've done the top, the right side, the bottom. The left side that I cannot see, I need to flip that side down. That's also 17 units by 17 units. I then need to flip down the front here. It's, again, 17 units by 17 units. I flip down the back. It's 17 units by 17 units. All right. So B says, explain why the area of each face of this cube is 17 to the second power square units. All right, so we know area is equal to length times width, right? So in this case, each face has a length of 17 and a width of 17. So the length is 17, the width is 17. 17 times 17 is just 17 to the second power. So that's why we could express the area as 17 as the second power, because that's 17 times 17, which is the length and the width. All right, C says write an expression for the surface area in square units. So this is a little weird. This is probably not something you guys knew how to do, because the idea of writing an expression is probably a fairly new thing to you in 6th grade. It's not something you do a lot in elementary school. So the surface area up here, if I think back up here, first I got this 25 by doing 5 times 5. So here I'm going to do 17 times 17. That's going to give me the area of one face, of just one of these faces. All right? There's 6 of these faces that are all the same. So after I found this area, I did times 6. So I'm going to do 17 times 17, and then I need to multiply that by 6. All right? So this would be an expression. This would be perfectly fine. I'm going to simplify it a little bit more, though. I'm going to say this is 17 to the second power. That's the area. And then I can do that times 6. That's going to get me the surface area. All right, any questions on that? All right, so now write an expression for the volume in cubic units. So the volume, we know volume is length times width times height. So the length is 17, the width is 17, the height is 17. So 17 times 17 times 17. This could be the expression. How I'm going to write it, though, again, I'm going to write it with an exponent. 17 times 17 times 17 is 17 to the third power. All right, any questions on those, any of those?